triangles. This is part 2 or part B of question number 9 of the March 2018 paper 32. So it says here, sorry, it's part B, it's part 2, sorry. It says on the Argand diagram, remember the Argand diagram is a real and an imaginary part, or the x-axis being the real part, the y-axis being the imaginary part of our complex number. They want us to sketch the locus of points. Remember, a locus is a path of points representing the complex number z, which satisfies the equation z minus u, and u being that number that we had in the beginning, 1 plus 2i, must be equal to 1, and they put this in absolute values. Well, let's see what they mean by this. So firstly, let's take this point C here, which is the value 1 and 2i, or 1 plus 2i, okay? It is 1 plus 2i, and that means it's 1 on the real axis and 2 on the imaginary axis. So that is our u value over there. Now, if we take another value z, and we are 1 unit away from that, remember, a circle represents something that is 1 unit away from anything, or from a point, okay? So then this number z has to be any of the complex numbers on this circle around here. And this circle must have a radius of 1, because the distance, the absolute value of z minus u is 1. So that's what we've given, and it says they now want the least value of the argument of z for the points on this locus, giving our answer in radians correct to 2 decimal places. Alright, so what they're saying is, if I draw a straight line, and let's use a ruler for this, and here is from my center, okay? If I move my ruler, what is this angle over here where it just touches or makes a tangent with this circle? Now, there are 2 places where this will happen for that circle. So let's just move the ruler nicely over there. And the other one here along the y-axis, or the imaginary axis. You see, if I rotate that line from the horizontal line and I create an angle, the first time I hit the circle, this angle will be the least, and the last time it touches, that angle will be the greatest. Now we can see that the greatest angle comfortably can read as pi over 2, or 90 degrees, okay? But the question is, what is the angle here, theta, for the time when it just firstly touches this circle? Well, what I'm going to do is I'm going to draw another line, and we're going to draw this to the center, because we know that value of that point at the center. Now, you'll remember from some geometry that you might have done a while back, that if I draw from the center of the circle to the tangent, we form a 90-degree line, and we do the same thing over here. And that the 2 tangents are equal in length for a circle, okay? So, do we know the value of the 1 point here, or the 1 length? Yes, we do. We know that this is 1 and this is 1, because they're both radii. And can we work out this length over here for the 90-degree triangle? Of course we can, because we know that the point is 1 along the x and 2 along the y, which means that this one must be root 5 using some Pythagoras. So now we've got a 90-degree triangle, which I'm just going to draw out here quickly. here is the 90-degree triangle with a unit 1 and with a root 5, and we want to know this angle over here. Okay, now that's easy enough to find, because if we go 1 over root 5 and we invert cos for that, or we say cos of that angle is 1 over root 5, we can find the cos of that angle, and then we can find the angle. So 1 divided by root 5 and the inverse. Sorry, that will actually be the inverse sine. Okay, that gives us 0.46, which we can double because that there are two angles, so that gives us 0.9272. So these two angles here make up 0.9272. Of course, we know that this whole angle over here is 90 degrees, so we can say that pi over 2 minus the 0.9272 must give us the angle we're looking for over here. So let's do that, and we're going to go pi divided by 2 and subtract the angle which we found, and that gives us an answer of 0.64. So the angle here, theta, is 0.64, and of course that's the argument for, or the least value of the argument in radians for the locus of the points that we were discussing. Alright, so that's a very nice question to work through. Make sure you understand what we're doing there. Certainly you need to apply some good geometry skills here if you're going to solve that question, but there it is. Enjoy the rest of your day, and we'll be in touch.